All right, in Unit 5, Section 1 here, we're going to be talking about solving systems by graphing. What does that mean? Well, what I'm referring to is solving a system of linear equations. And what does that mean? Well, a system means more than one. In our case, we're going to be talking about two. We're going to be talking about two linear equations. What are we talking about with linear equations? Well, when you graph a linear equation, you get a line. So we're going to be graphing two lines at a time. That's what all this means. Well, before we get into graphing two of them at the same time, let's have a little refresher here on what it takes to graph any line. In number one, we have y is equal to 1/3 x minus 1. This equation is in slope-intercept form. The slope is 1/3, and the y-intercept is -1. What we're going to be doing is we're going to be going over here to -1 on the y-axis. And then from there, we're going to rise 1 and run 3 and put another point here and here. And I'm going to follow that pattern all the way up and all the way down. And I'm going to be able to draw a line. And there it is. In the second example, we're going to be taking 3x plus y is equal to -4, and we're going to solve for y by subtracting 3x from both sides of the equation. That'll get me the y is equal to -3x minus 4, where the slope is -3 over 1, and the y-intercept is -4. That means we're going to be starting at -4 on the y-axis. We're going to go down 3 and right 1, but that takes me off the graph. So I'm going to go the opposite direction and go up 3 and left 1. Up 3, left 1. Keep following that pattern all the way up the page, and from there you'll be able to draw your line. And then in the last example, 2x minus 3y is equal to -9. I'm going to solve for y, again, by subtracting the 2x from both sides. Now remember, that'll leaves you with -3y is equal to -2x minus 9. And then dividing everything by -3, we get y is equal to double negative makes it positive, 2/3 x. Again, double negative, positive plus 3, where the slope is 2/3 and the y-intercept is positive 3. So I go to positive 3, put my point, rise 2, run 3, down 2, left 3, and that'll give me this line. So there's your refresher on what it takes to graph lines. Well, when we solve a system of equations, what happens when you put two lines on the same graph? They're going to intersect, and that's what we want. We want the point of intersection. Where do these two lines meet? That will be the answer. Now we're going to determine how many solutions each system of equations has using the coordinate plane given. In other words, here's what we're going to be doing. I need to find this line on this graph. Then I need to find this line on the same graph. And all I'm doing is determining how many solutions there are. So here's where those two lines are. Y is equal to -x minus 3. You can follow that arrow and find that line. Y is equal to x minus 1. Follow that arrow, get that line. And you can see that these two lines intersect right there. So how many solutions? There's one solution. There's one point that they have in common. In the second example, if we take 2x plus 2y is equal to -6 and solve for y, we get y is equal to -x minus 3, which is the same as this line. So in fact, the fact that they're both the same line, how many points do they have in common? And we're going to say that there are infinitely many solutions in common because they are the same line. In the next problem, because we have y is equal to -x minus 3, that's this line again, y is equal to negative x plus 2. That's this line. Where do they intersect? That's right, they don't. There are no points in common because they're parallel. And because of that, there's no solution. They don't have any points in common. And then the last example we have, let's take the second equation first. We have 3x plus y is equal to 3. And solving for y, we get y is equal to negative x plus 3. That is that line right there. And y is equal to negative x minus 3. That's this line right here. And we'll see that they do intersect down here, and they have 1 point in common. I will tell you right now, class, that this problem right here you will see on your chapter test. So study this carefully, know what we're doing, and we'll discuss it more in class. But basically, here's what we're doing. We're going to take each line, y is equal to negative x plus 2, or we're going to graph this line, y is equal to negative x plus 2. We go to positive 2 and down 1, right 1 because of the slope is negative 1, and we graph the line. And then we're going to take y is equal to x minus 4, and we're going to graph that line. So where do we start? At negative 4 on the y-axis, rise 1, run 1, and draw that line. Make sure you use a straight edge here, please. Take your lines all the way across the graph. Now, here's what I would do. I would circle where they intersect, because what I want to know is, what are the coordinates of that point? And we have 3, negative 1. So that's what we're going to be doing. Now, in number 2, x equals 2, special kind of line. Do you remember how to graph this one? Well, we want to know where is x equal to 2. How about right here? It will be a vertical line going through that point. So one line is here. The second line, we need to solve for y. We're going to subtract 2x from both sides. Y is equal to negative 2x plus 1. Where do we graph that? We start at positive 1. On the y-axis, we're going to go down 2, right 1. Follow that pattern all the way down the page, all the way up the page. And again, please be sure to use a straight edge when you're drawing your lines. Where do these 2 points intersect? Right here at 2, negative 3. This is the answer we're looking for. Where do they intersect? In number 3, y is equal to negative 3 halves x plus 3. Go to positive 3 on the y-axis. The negative is going to move up with the 3. The slope is negative 3 over 2. So I'm going to go down 3 and right 2. Up 3 and left 2. Follow your pattern all the way across the page using a straight edge to draw a straight line. We don't know where these 2 lines are going to intersect, so take your line all the way across the graph. And then we're going to take 3x and subtract it from both sides. We get 2y is equal to negative 3x minus 4 will be the slope-intercept form. Dividing both sides by 2, dividing everything by 2, we get negative 3 halves x minus 2. So we start at negative 2 on the y-axis. We'll go down 3, right 2, up 3, left 2. Follow that pattern. Take your line all the way across the page. And where do these 2 lines intersect? That's right, they don't. These lines are parallel, so there is no solution. There is no point in common. Now notice on number 4, when you take the second equation and solve for y there, you get y is equal to 3x minus 10. But my graph doesn't go to 10. Well, it does if you double everything. This is going to be negative 2, negative 4, negative 6, negative 8, and negative 10. So we do have a negative 10 here. Rising 3 and running 1, we're still going to rise 3 spaces, run 1 space, and we'll be good to go there. How about 2x plus 2y is equal to 12? Subtracting 2x from both sides, 2y is equal to negative 2x plus 12. And y is equal to negative x plus 6. Well, again, we've doubled all of our numbers here. So here's 2, 4, 6. We're going to go down 1, right 1. And when we come up with our point of intersection, we come up with this, which is 2, 1, right? Careful, we've doubled everything, so this is actually 2, 4 to the right, and 2 up. Our point is 4, 2. So be careful on a problem like that when you have to alter your intervals. In number 5, y is equal to 2x plus 1. Should be fairly simple. Starting at positive 1, rise 2, run 1. In solving for the bottom equation, we're going to divide everything by 2. And we get y is equal to 2x plus 1, which is the same line. So there are infinitely many points, infinitely many solutions here in common. In number 6, y is equal to 1/2 x plus what? This is our y-intercept. What's out there? 0, right? So we go to 0, rise 1, run 2, down 1, left 2, and follow this. Again, we're following this pattern all the way up, all the way down the page. And when we take x and subtract it from both sides, you get y is equal to negative x plus 3. So we go to positive 3, down 1, right 1. Draw your line. And these two lines cross right here, which is the point 2, 1. Now, for renting video, and this is how this we're going to be using this is in story problems. For renting videos, Nina pays $6 for a rental card and $2 per movie that she rents. Jane doesn't pay for her rental card, but her movies cost $4 per rental. Write a system of equations to represent this situation. Well, what's happening here is that Nina ends up paying for her videos. So does Jane. And we need to write equations in slope-intercept form. Well, here's the thing. When you're writing equations in slope-intercept form, first of all, here's Nina's sentence, and here's Jane's. So what does Nina pay? She pays $6 for a rental card and $2 per movie. So in other words, her final cost, what would be her cost? Well, that's going to be the y. And what's her final cost going to be? Y equals, well, what we're going to do now is find the word per, each, rate, speed. In any story problem, when you see any one of these words, well, they're talking about the slope. So which word do we see here? Per. $2 per movie. Per means we're going to be multiplying $2 times the number of movies. Let's call the number of movies x. So we're going to have 2 times x plus, what did she start to pay in the beginning? Is $6. So the equation for her would be y is equal to 2x plus 6. On the other hand, Jane doesn't pay for her rental card, but hers are $4 per movie. So that means hers is y is equal to $4 times every movie. Now she doesn't pay for the card, so we actually, it's actually plus 0, but we wouldn't write that, correct? And that is the y-intercept though. So now we need to graph these because it says to graph the system of equations. Well, x being the number of videos, we're going to put across the bottom axis. So let's put maybe 1 video here and 2 here, 3, 4, 5, and 6. And then what's the cost going to be? And let's do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Just as long as your intervals are consistent, won't be a problem. All right, so Nina's. Her y-intercept is 6. Her slope is 2. Now, since our intervals are not the same here, we need to adjust for that. So she's going to rise 2 videos, or $2, I mean, and run 1 video. So actually, her line would look like this. In other words, let's say she was renting 6 videos. How much would it cost her? Well, 2 times 6 is 12, plus 6 is 18, and that's what we've graphed here, is 6 videos would be $18. So let's graph that line. And what this represents is the cost of any number of videos that she might be renting. Then we're going to do the same thing for Jane. Now, she doesn't pay for her rental card, so it's going to be 0. But she pays $4 for every rental. So we're going to go up here to 4 and over 1. Up 4 and over 1. Up $4, run 1. So her video rental line is going to look like that. Now, the big question is, how many rental movies does it take for Nina and Jane to pay the same amount of money? Well, here's where they're paying the same amount of money. How many video rentals is that? 3. Well, we will be talking more about this in class. Have a good day, and we'll see you then.